analysing another H-NMR spectrum. Starting with the start point, we've got 3 hydrogen environments because we've got 3 distinct peaks here. We've got a 3H, so therefore we're going to probably have a CH3 there. This guy's going to be a CH2 there. This guy's going to be a CH3 because this is the integration. This is the size of our peaks. It's given to you nicely showing a 3H, so therefore they're being very kind there. What else have we got? We've got a no splitting here, so that's going to be put to a carbon or an oxygen with no hydrogens next to it. This guy here is split into a quartet, so therefore he's going to be most likely next to a CH3, and this guy here has been split into a triplet, so therefore his neighbours will probably be a CH2. Again, we're following the N-1 rule for finding the neighbours of our carbons, so our neighbours of our hydrogens. Next point is to look at our chemical shifts. Now this guy down here has got nothing really interesting going on at all, so therefore he's most likely just being an alkyl group by himself. Sitting up here around the 2 point something suggests he's got some oxygen or something else going on here. So I'll have a look here. So that section there suggests he might be a carbon double bond to an oxygen, or we might have an ester group coming in here as well. So therefore that's that section there, might be next to a ester. This guy over here is right up the top there, so let's have a look at a 3.5. A 3.5, again, suggests he's right next to the oxygen bonded to an ester, so therefore all these guys here suggest ester functional group. Ester functional group also is kind of indicative of this O2, so therefore let's start drawing an ester with 3 hydrogen environments, 4 carbons, and see what we come up with. So let's start off with our CH3, which we know is present because we've got a CH3 here. He's bonded to a CH2, and that guy's going to be bonded to our oxygen of our ester, which then puts our ester in here and a CH3. How many hydrogen environments do I have? 1, 2, 3 unique ones. What's the integration here? I've got 3 to 2 to 3. That kind of fits there. This guy here should be split into a triplet because he's next to a CH2. This guy here should be split into a quartet because he's next to a CH3. And this guy here should be there by himself. This guy fits the bill, so therefore that is our molecule based on the analysis of this spectrum.